Okay, let's give you guys some more practice. So given this graph here, work out the distance traveled between time 5 seconds and 8 seconds. So press pause and have a go. Whenever you're given a graph, try to visualize the three graphs inside your mind. So you've got acceleration time graph, you've got the speed time graph, and then you've got the distance time graph. And which try and identify which. So I've given you this graph here. So inside your mind, visualize your three graphs and try and identify which graph I'm talking about. In this case, I'm talking about the distance time graph. So once you've got this inside your mind, it really helps. Okay, so given this graph here, find out the distance traveled between 5 and 8 seconds. So press pause and have a go. Okay, so when you're given when you're given a graph, like the first thing you should do, visualize the three graphs. So acceleration time graph, um, uh, speed time graph, and then you've got yourself a distance time graph. So here you are given well, your eye should zoom into this first, and then you can see it's a distance time graph. So we are talking about this graph here, and and here is just a straight line here. So the distance is always the same. You know, if you have an acceleration, that's if you drop a cannonball or something of a building, the acceleration is like this, the speed will be like this, the distance would be like this. But here, the distance is just a straight line. So what that means is that, well, the distance traveled here is just a straight reading. When you are looking at the distance time graph, it's a straight reading. So you normally look at the y-axis. So it's just a straight reading. Whereas this one here, you have to work out the area underneath the graph to work out the distance traveled. But because we are dealing with a distance time graph, it's going to be a straight reading. Well, this is a trick question. The distance traveled between 5 seconds and 5 seconds will be 0. Okay, just looking at this graph here, the distance traveled between 5 and 8 seconds will be 0, because what this means is if you look at this here, say you're sitting in a car with your dad, what this graph here represents is the distance. Well, this is a distance time graph. So to translate this graph into this situation here, this is a start. At time equals 0, which is here, at time equals 0, the distance is already 4. So you start here, well, the distance at time equals 0 is 4, because you and your dad, you're both 4 meters away from the start at time equals 4, at time equals 0. Now at time equals 1, well, at time equals 1, you're still 4 meters away from the start. At time equals 2, well, you're still at this point here. You're still 4 meters away from the start. At t equals 4, you're still 4 meters away. At time equals 5. Now the question is, what is the distance traveled between 5 seconds and 8 seconds? Okay, time equals 5, so you start here. Okay, time equals 5, you start here. Now 6, you're here. 7, you're here. 8, you're here. So time equals 5, you're here. And then time equals 8, you're still here. So what's the distance traveled? Is 0. Okay, so it's really a trick question. Okay, next question here. Now, given this graph here, what is the distance traveled between 5 and 8 seconds? So press pause and have a go. Okay, so whenever you're given a graph, like, well, try and visualize this inside your mind. Identify which graph we're talking about. So you've got your acceleration time graph, you've got your speed time graph, you've got your distance time graph, and identify which graph we're talking about here. We are talking about speed time graph. Okay, so we inside your mind, you should be visualizing the middle graph. And well, the distance here the speed here is always 4. Now the speed here is always 4. But by the way, if you have a speed time graph that's like this, then the gradient of this line is 0. So the acceleration is 0, meaning that there's no acceleration. The acceleration is 0, so that means there's no change in the speed. That's why it's always the same. Okay. Whenever you have something like this, there's a change in speed, or something like this, there's a change in speed. There's a change. Whenever there's a change in speed, there's an acceleration. But here, the speed is constant, so there is no acceleration. Well, anyway, back to this. What is the distance traveled between 5 seconds and 8 seconds? And remember, because we are talking about the speed time graph, the area underneath the graph represents the distance traveled. So if you have the speed time graph looking like a straight line like this, the distance covered will be something like this. Okay. Well, anyway, we don't actually need this. You want to know the distance traveled between 5 seconds and 8 seconds. So here, the area underneath the speed time graph represents the distance traveled. So here, this is not a trick question. You need to work out the area of this here. So the area of this is this here is 3. Okay, 3. Now the speed, the height here, if you like, we need to work out the area. The height here is the height here is 4. Okay, the height. Well, we need to work out this area here. Okay, so the height is 4. The width here is 3. So just get this times this, which is 12. So the distance traveled is 12 meters. Okay, the distance traveled between 5 seconds and 8 seconds will be 12 meters. Okay. Yeah. Okay.